Hello everyone, welcome back to my channel. I hope you guys are doing amazing. So in today's daily challenge of Leetcode, I will show you two approaches. Both are O of n time complexity, but one is 26n and another is O of n plus 26 square. So definitely this one is much better, and I will show you how exactly to arrive at the intuition. So definitely subscribe to my channel if you because it gives me motivation to make better videos, and do follow my DP playlist where I am teaching DP for from scratch to advanced. So let's try to see the problem statement at first. Minimum deletions to make a string k special. You are given a string word and an integer k. We consider word to be k special if the frequency of two letters in the words is less than equal to k for all the such I and j. So any two letters in the word you take and you want the frequency of them to be less than k. That is, you want them to lie within a window. So here frequency of x denotes the frequency of character x as it is told, and y denotes the absolute value. So this denotes the absolute difference, and return the minimum number of characters that you need to delete to make the words case special. So you can perform operations which is denoted by only deletions. You can only perform deletions, and you want to return the minimum number of such deletions you need to make this word case special. Okay, so as you can see here, some examples are given. Equals to 2, it means that we can make a word too special by deleting occurrence of a and occurrence of d. Therefore the frequency becomes within this range of k. So let's try to understand what this k means a little later. Let's try to figure out. So let's try to figure out things first. Okay, how will you think by looking at the problem first? So first thing which comes to mind definitely is to make a frequency array. Okay, so you have all the characters you see. This is a string, and it consists of lowercase English letters only. So it means that you have only 26 characters that will be possible. So it is definitely beneficial to store the frequency of all of them, right? So let's say I am storing the frequency of all of them in some manner. Okay, so till z. So let's say I'm drawing a bar graph, which the height denotes the frequency. Okay. So let's say this is a small frequency. B, let's say, is the frequency of this height. Okay. And C, let's say, the frequency of this. D is, let's say, this. Okay. So I am drawing a bar graph. I am drawing nothing but a bar graph showing the frequencies. So let's try to think. Let's try to think in this manner. Uh, you have, let's say, this C frequency, this frequency of C, let's say, it should have a little more, let's say. Okay. So, and so on. So what can you do? What can you think to do? Okay. If you try to reduce all the frequencies to a particular value, we will think about k, what that k means later on. Okay. So now, as of now, I am thinking that definitely we need to make deletions, and I need to reduce the frequencies of some. I need to increase the frequencies of some. You can understand, like you cannot increase, you can only reduce. And by only reducing, I need to bring all the values to a same frequency. Not same frequencies in the question, but here let's assume I need to bring all the frequency values to this level. Okay, so this y-axis denotes frequency. You already understood that, right? Since it's the height of the bar graph. So what will happen? I can make deletions only. I cannot make increments. So whichever is below me, whichever graph is below me, if I want to convert all my frequencies to this, whichever graph is below me, I will delete that. I will delete the whole thing. And whichever is above me, I will delete only the extra frequencies. I will chop off these extra frequency values only. Okay. So if you see, what I am going to chop off exactly is these extra frequencies. Okay. So if you see these extra frequencies, I am only going to chop off, and nothing else, and nothing else. So that I can do. Let's say I have this frequency, then I can go through all the letters A, B, C, D. If I see that anything is less than this frequency, then I can just delete the whole thing. And if something is greater than the frequency, let's say this frequency is, let's say, fi, then I will delete only fi minus f. Only this length I will delete. Only this length I will delete. Here only this small length. here only this small length, again there this small length, I will delete it. Okay, so this is when I want to bring all the frequencies to a single frequency value. Now you try to see, but what does the question says? Question says the difference between any two frequencies must be k. So difference between any two frequencies of characters must be less than or equal to k. This means nothing but frequencies, all frequencies. Okay, this means nothing but all frequencies must lie within a window range of k, within a window length uh, of k. Okay, so that's what it means. That much it means. Frequencies must lie within a window range of k and not a particular frequency. So if you try to draw now, the same thing as I told you, the exact same thing as I told you, that uh, let's say you have a small frequency, and now you have this kind of frequencies, then this, then let's say this. They may not be in sorted order, right? So they may not be in sorted order at all. So what is the thing that you need to understand is that let's say we have these frequency values, and earlier we were reducing all the frequency to a single frequency. This thing means nothing but the frequencies must lie within a window length of k. So what does that mean is that let's say our window length is something this. Okay, this is okay, this. So this window length is k. Okay, so I want to see that where should I put my window? Should I put my window here? Then what will happen is that I will need to delete this whole thing. I need to delete this whole thing as it lies completely out of the window. I need to delete this whole thing. This frequency, I only need to delete this portion. This frequency, only need to delete this small portion, and other we don't need to delete it at all because they all fall within the k range, right? So my question becomes, where should I put? Where should I put my k window? Okay, where should I put my k window? The question is that. The question reduces to, where should I put my k window to have minimum deletions? To have minimum deletions. Okay, to have minimum deletions. So I can just traverse that in a loop and check, right? So let's say, what should be this? Should this be the length? Okay, if I am taking the frequency k value to be this instead of the upper one, then you see I need to delete these whole portions, again these portions, these portions, this whole portion I need to chop off, right? So I need to see that which frequency can be there. Okay, so how will I decide this window? How will I decide this window? So for instance, I am telling the approach which came to my mind first, and then I will tell you the most optimal ones. Okay, both works, both are of O of n. So what can you do is that you make some target frequencies that is in the middle. Okay, this is nothing but a line in the bar graph, horizontal line. So you consider this as a target frequencies. Okay, and this, your window is within this range. Okay, this is your range of windows, and you want to iterate. You want some fixed value which you need to iterate, right? So you need some f, and this is your window length k. Okay, so if k is even, if k is, let's say, even, what you can do is you can check k by 2, k by 2. So you, for all frequencies, for all target frequencies, let's say you are iterating through all the target frequencies starting from 1 to some max frequency. Okay, to some max frequency, starting for, you check through all these max frequencies, and every time you check a window length of k by 2 and lower and upper window length of k by 2 and k by 2. If k is even, what if k is odd? You can do nothing, you can do the same thing almost, but let's say k is 3, then k by 2 is 1, and then k minus k by 2 is not equal to k by 2, that is 2, right? So what you can do in this case, what you can do is simple, is that you can, for odd case, to make a window of k, let's say you are iterating through this target frequency f, And you can make this ky2 upper limit, okay, L. You can call this upper limit L, and lower limit, let's say, you can call R. And this is nothing but k minus k by 2. Okay, k minus k by 2, and definitely this value L is nothing but f plus k by 2, and this is nothing but f minus k minus k by 2. This length you are subtracting. So what you are doing exactly here is that you are finding a window length of k. Okay, you are finding a window length of k, and in a way you are moving the whole window. You are moving the whole window. So you realize what I am doing exactly? You want to, first of all, you understood that you want to find a particular window length. So you want to move the whole window starting from f equal to 1. So let's say f is 1 here. Then window will be something from this to this, length is k. Okay, then f equals to, let's say, 2 here. Okay, let's say 2. Then window will be something from this to this. Let's say again the f now goes to some 3. Okay, then f value goes to some 3. Okay, then again window will be from this to this. So f values, you see, f value moves, let's say, from let's say this is 1 to this, downwards is increasing, let's suppose. So you are traversing through all possible frequencies and checking through the window lengths of k. So you are checking through all the window lengths of k, and you want the things which are more less than this window length. I want to chop that bar graph off, and if anything is more than this window length of frequency, I want to bring that frequency into this. So it means that I want to chop only the upper portion. I want to chop only the upper portion. Okay, so that's what you need to do here. Let's try to understand the coding part, and I will also simultaneously explain the code. So if you have not understood that well so far, you bear with me. In the coding portion also, I will definitely explain you. Okay, I will definitely explain you, and it's not that difficult. It's not that difficult. It's quite simple only. So I will take this window length. So what I will do at first, as I told you, is that I will store values, frequency values. So at first I extract this n that I always do in the beginning. And then what happened is that you can create a vector of size length, let's say map 26. Okay, so this is the frequency array that you are having, and you want to go to the each length of the word. So auto, as I am doing auto C, you are going through all the characters in the word and just iterating in the map, and doing map of C++. Okay, so you have stored the frequency of all the characters. Now what you should do, you should definitely have an answer variable outside the for loop. And now how should the for loop be? As I told you, I am iterating through a particular frequency, right? I am taking one f, and I am moving the whole window also along with f. Okay, so first of all, I need to say that what is my upper limit and lower limit. So let's say the upper limit, left limit, you can say, or upper limit, okay, is nothing but what is it? It is nothing but k by 2, one length. Okay, and what is my lower limit? I'm using upper and lower UR and LR. Okay, so lower limit is nothing but k minus k by 2. Okay, so if you try to go through all the frequencies, as I told you, target frequencies, I equals to 1 to, not I, let's consider it as f. Okay, from f equals to 1 and go to f less than equals to max, f plus plus. So you need maximum frequency also, right? Whichever is the maximum frequency out of all these words, whichever is the maximum frequency, only that, I mean, you are moving through the window, and window is within the frequency bar graph, right? Window is within the frequency bar graph. So maximum frequency is the one which is having in the maximum value of the bar graph. So you just find that one. You just find that one in a while loop, in a for loop. You just go through that. Okay, and you just update maximum of, you can do x also, right? Instead of doing all this, you can do just x. You want to iterate through this map. Okay, so this frequency map, you just want to have this maximum value. Okay, so you have the maximum frequency now. I am iterating through all these maximum frequencies, and every time I'm going to go through all the characters and check that which is within my window and which is outside my window. Okay, so I will go through all the characters which is given by nothing but I equals to 0 to I less than 26. Okay, so I'm going through go through all characters to find which lies within my window, which lies within window. Okay, now what you need to do is perform some deletions. Okay, so you need to count the number of deletions. Okay, so I am doing del equals to 0, so that means the number of deletions count. Okay, and you need to minimize the deletions count also, right? So at the end I will do nothing but answer equal to minimum of answer comma deletions count. Okay, and how do I need to calculate the deletions count? So I will check that instead of this map, why don't we keep this name as frequency? Because it is a frequency array, right? So I will keep this as frequency FREQ. Okay, so I will go through all the characters. Okay, so what will I do now? What will I do now? I will check that if my current frequency of I is less than what the case I am taking is that if my frequency completely lies below the window, so it means that my frequency lies something which is less than this f minus lower limit, right? Yeah, f minus lower limit. You can understand this easily. So f minus lower limit, this frequency is lying even less than that. So then what did I need to do? I need to add the full value to the frequency deletions. Why? Because I need to delete the whole thing. Okay. So this I am doing deleting the whole bar. Okay, whole bar. So this means that I am deleting all the frequencies of that. Okay. Else if my frequency value is greater than that upper limit, if it is even greater than that upper limit, what should I do? Upper limit. Okay, UR. Upper limit is nothing but f plus UR. If it is even greater than that upper limit, what should I do? What should I do now? I need to chop off that particular value. So what is this particular value? uh let's calculate. So let's say this is nothing but frequency of I. So this is now nothing but frequency of I need to calculate this length. Okay, this is nothing but f plus upper limit. So this is nothing but frequency of I. Okay, frequency of I minus f minus upper limit. Okay, you just subtract those. So deletions will be plus equals to frequency of I minus f minus upper limit. So you got it. Uh, that's how you calculate all the deletions. And if it lies, if else nothing, we do nothing, right? If else do nothing, because we don't need to delete any character. It lies within my window. If these two conditions are not satisfied, it means that it lies within my window, and all we do is just return answer. That's all we need to do. Okay, let's try to run it and check. Let's try to run it and check if it works, or did I do some mistake. Okay, so I am getting a runtime error. So let's try to check where is my fault here. So this frequency of C you need to add, and this is nothing but character, right? So this character must be, I am storing this as an integers, right? But these are characters, so I'll just store them in this way. Okay. Let's try to check now. What happens here. We are getting a wrong answer now, so definitely there is some error in the logic. Let's try to check from the beginning. Frequency of 26, we have this thing, and we are calculating the maximum value of frequency. Answer is 0 initialized. We have k, the upper limit and the lower limit. Okay, so as I am checking that f from all the ranges of f, I need to find the number of deletions. So if frequency of I, what is the frequency of I? Yeah, the ith frequency of the character. if it is less than the f minus LR. So if it's even less than this frequency, just delete the whole thing, delete the whole thing. And if the frequency of I is greater than f my plus upper limit, okay, uh, f plus upper limit, then you just delete the particular thing only, okay. Then you do okay. This is a very silly thing. Okay, you see the answer equal to minimum of delete comma answer. So this has to be initialized to some large value, right? Answer has to be always a large value. So what is the maximum number of deletions you can perform? N. You can delete all the characters. That is the maximum you can do, and you need to minimize the deletions. So you need to don't initialize the answer by 1. That's a really silly thing. Okay. Otherwise, always the answer will come 0. Always the answers will come 0. We have the accepted thing. If we try to submit it now, uh, we have accepted, but you see our runtime complexity is not so good, not so good. So what you can do is, what you can do here to improve, what you can do exactly. So if you see little bit different approach, not the same one, almost the same one, right? So what you do here is that, let's say you are having these kind of graphs, these kind of bar graphs you are having, and what you need a window length k. So how will you initialize this window, right? I have, if you change the way of initialization of the window, so I have initialized this nothing but f and f plus some upper limit and f minus some lower limit. Okay, I have done it in that way. But what if you do in something like you iterate through the lower element? I am iterating through the f, right? But I iterate through the lower limit of frequencies. So that is f, and I go through all the frequencies to f plus k. Okay, the window length is k, right? So I go through all the frequencies of f plus k. What will be the benefit of this? The benefit of this will be that this f will lie within the frequency array, because the lower frequency will lie within the frequency array. So what I can do, a limit definitely lies within the frequency array. Okay, so what I can do is very simple changes in my code. If I don't need this upper limit and lower limit at all, now my upper limit is nothing but the lowest frequency. So the lowest frequency, if you see, I will iterate through the lowest frequency through all this frequency array. I will call it lowest, capital L. Okay, the lowest frequency. And what I will check is that if my answer is less than the lowest frequency, you just remove all of them. And if it is greater than my lowest frequency plus the k within the window, you just subtract this. Okay, just because of the same logics, exact same logic. So if you try to do this, you see L is iterating through the frequency array only. So this becomes, instead of n, this loop, instead of n, it becomes 26 cross 26. Okay, but anyways, you need to go through the n, right? You are creating the whole map. So anyways, you are going through the whole string. So O of n you cannot avoid. So if you try to run this code, if you try to run this code, it works, and I guess it will give you definitely better than 5.8% beats. It will definitely give you yeah, better than better runtime as well as memory complexity. So you see here the complexity is nothing but this is 26 cross 26. Okay, this was 26 length, and this is also 26 length. So the complexity here is nothing but O of n plus 26 cross 26. Okay, so if you see, that was all. That was all for this problem. If this problem is kind of doable, but if you are not approaching in the correct way, this is definitely a difficult problem. If you do not approach in the correct way, you might get caught up in a multiple if and else statement. You might also try DP. I think DP might also work here, but this is not something you need to overkill the solution. So right, yeah, that's all for this video, and I will meet you in the next video. This was a medium kind of problem, but I hope your day is going to be really easy, and keep following my DP playlist too. So yeah, that's all. Thank you so much.